Hi class, today is lesson 11. Today's not 11. Today I'm going to teach a lesson, not the number 11. Anyway, today's lesson is lesson 12-4 on theoretical probability. This will be our fourth lesson, of course, there's a 4, hello, on probability. And let's go ahead and take a look at our purpose. Our purpose is to find the theoretical probability and the complement of an event. Boy, I forgot a period there, by the way. Let me put one in there. There, doesn't that look better? So theoretical probability, a term that we don't know, complement, a term that we don't know yet. So guess what? We have some vocabulary. Let's go ahead and take a look at our vocabulary. Turn to the back of your composition books and record about 4 terms and their definitions there. Theoretical probability. Theoretical probability is the ratio of outcomes desired to the total possible outcomes. Ratio of outcomes desired to the total possible outcomes. This is different from experimental probability. And that experimental probability is always based upon experiments that have happened, and we look at the data. Here we don't have any data to look at. All we have to look at are potential outcomes. What do you think will happen? What's the probability of a 5 being rolled on a number cube? Well, we would assume that it's going to be 1 out of 6. One outcome desired out of a total 6 possible outcomes. So that's the difference between theoretical probability and experimental probability. Experimental, based upon data. Theoretical, based upon what we think will happen based upon our knowledge of the potential outcomes. Equally likely. Equally likely's definition is when all outcomes have the same chance of occurring. Now this can occur, oh my goodness, isn't there an R supposed to be here? Let's go ahead and put that in there. Looks like a V. Sorry. When all outcomes have the same chance of occurring. Equally likely outcomes are like the flip of a coin, the roll of dice. Each flip of the coin has an equally likely chance of being heads or tails. With a one standard number cube, you have an equal chance of getting a 1, 2, 3, 4, 5, or 6. And here with this spinner, since all of these sections of the circle are of equal area, there's an equally likely chance that this spinner will land on either A, B, C, D, or E. Next vocabulary term is fair. Now, what is fair? It's not what happens down at Puyallup, at least not here in this lesson. It's an experiment with equally likely outcomes. So a coin, when you flip a coin 25 times, it's a fair experiment. When you roll a dice in any game, it's essentially going to be a fair experiment. I think this is our last vocabulary term. That term is complement. Complement is all other outcomes in the desired outcome. And we'll give you an example of that. A desired outcome plus the complement of that outcome will equal 1. For example, if the probability of rolling a 5 on a die is 1 out of 6, then its complement of all other outcomes will be 5 out of 6. So that's the complement of this desired outcome. When I add 1 out of 6 and 5 out of 6 together, they come up to be 1 whole or 100%. Next, we've got an example. What's the probability of rolling a number less than 5 on a fair number cube? Well, here's where we look at the sample space. Sample space being all the possible outcomes, and you notice the brackets there, so make sure you write in the brackets. What is the probability of rolling a number less than 5 on a fair number cube? Well, let's look at the possible or desired outcomes. There's if we roll a 1, a 2, a 3, or a 4, we have accomplished that. So the probability of rolling less than a 5 would equal 1, 2, 3, 4. 4 outcomes out of the total 6, which we simplify then to 2 out of 3, or 2 to 3. Next, we're going to look at complement, actually. So suppose there's a 10% chance of rain today. What's the probability that it will not rain? So the probability that it will rain is essentially 10%, or 10 over 100. We can go ahead and write this down as a percent. So what is the probability of no rain? Well, if we know that the complement plus a desired outcome of rain equals 100%, then we know that the probability of no rain will be 90%. 10% plus 90% would equal that 100%. So our answer, 90%. Complete the problem. There are two things that you need to do here. First is to give the example of a fair experiment. Come up with your idea of a fair experiment. And secondly, it's to describe the complement of the following situation. There's a 60% chance of snow. So what's the complement of that situation? Here's a hint, which is probably pretty obvious. They're asking you for what is the chance, the probability of no snow. And that, of course, is for number 2. So how do you figure that out? I think it'll be pretty easy. We'll see you in class.